Alright, ladies and gentlemen, let's add a rectangle that represents the paddle. So right now our game is really lame. Our game exists a ball bouncing back and forth, and you can see that I upped the speed just a little bit. I upped it to 3. If you look over here, you can see that I have changed the update speed to 3, which we did actually in the last video. And if you look at this, actually, we don't even have a game. This is purely an animation. That's it. It just repeats over and over and over again forever until the program is stopped. A game, by definition, requires the user to have some sort of input into the change in the variables in the game. So let's add that aspect today. So let's add a rectangle paddle. Where should we put that? Well, up here in this section, we have all the variables that our game is messing with. And is the rectangle a variable? Well, kind of. It represents a data structure that you can move around, and it has parameters that go up and down, but it's really not just a variable we're going to change from 0 to 3 to 5, or give it a name like Rhino or Waffle. It represents an object, and that's a bigger idea. So maybe we should put it in the setup. Well, the setup is a special function that only runs once and just sets up your processing window for doing whatever it is you want it to do. Well, the rectangle, we really want it to be active, so I think the most intelligent place to put it is in the draw function right here. This is the function that gets repeated with the frame rate every 80 times a second. This is the function that actually runs from top to bottom really often. So I think it makes more sense to put the rectangle here so that it will update every time that the whole game updates. So where should we put it? Well, I put my mouse right here because I think this is the best place to put a rectangle. And the code for rectangle, if you look in the API, is RECT. And the API for it is X position, Y position, I think width, I'm not sure, I might be wrong, and height. Well, these might be mixed up, but who cares? We'll just mess around with it until it works, which is kind of the best way to program, honestly. If you don't remember it exactly, you can go look it up if you want, but it's probably better if you just mess around with it to see how it works. So where do we want this thing? Well, we want the rectangle to sit right here on this side of the screen and just bob up and down so that we can hit the ball. So we're going to fix it to the other side of the screen, and we're going to say width minus 20. So we're going to keep it off this far side by 20 pixels. Remember, width is a special variable that you always have access to that's always equal to the exact size of the window. This is really useful because if someone resizes the window or wants to change your code, you don't have to change a whole bunch of random numbers. Width just changes with the size of the screen, which is nice. So that's where we want it to be in the X. In the Y, this position, we want it to match where the mouse is so that the user has control over it. So we're going to use a special variable called mouse Y. And you guessed it, that represents how high the mouse is on your processing window. Okay, now let's specify how big it's going to be. Let's make it 10 pixels wide. And let's make our game, a little bit easier. Let's make it, 80 pixels long. So let's look and see at what this rectangle does. You can see here now I have control over a paddle, but the paddle still doesn't interact with the ball. Notice that the stroke and the fill on the ball are exactly the same as on the paddle because we set those variables with stroke and fill. We didn't change them before we printed out the paddle. You might want to change the color of the paddle if you want. You can do whatever you like. But you can see here that wherever I put my mouse, the rectangle is sure to follow. Even if I put the mouse over here, because the code is looking at purely where is the y-axis coordinate of the mouse. Wherever that is, even though I'm all the way over here, my x-coordinate is goofy, my y-coordinate is right here, and you can see straight across the top, it's matching where my mouse is. And in our code, we're only paying attention to where the mouse is. If we wanted to make a more interesting game of Pong, we could do this. Mouse X. If we reload that, now we can move the rectangle wherever we want. And this will be more like air hockey. The physics of this kind of game will be much more complicated. So even though this works and it's pretty easy to do, to code for all of the bouncing and ricochets, that'll be too fancy. So we're actually going to go back and code this. So we're going to keep it pinned to this side of the screen. Okay, well now that we have a bouncing rectangle, that's cute, but it doesn't actually interact with it. So we need to come down here to where we control the behavior of the ball. And we need to say, okay, well when it hits, only if it hits the paddle, do we send it backwards? So this code is okay. This is the code for does it hit the left side of the screen. But this is the code up here for does it hit the paddle. And you can see that this code has nothing to do with the paddle. It has everything to do with whether it hits the other side of the screen. So what we need to change is this condition. Okay, so we need to say, does it hit the paddle? Well, that's interesting. How do we know if it hit the paddle? Well, first, is ball X greater than width minus 20? So we're going to put that in parentheses just in case. So width minus 20. So what we're saying is, did the ball get into the paddle? Basically, did it cross the paddle? Did it touch it? Okay, but that's not good enough because this will work no matter what. Okay, and what I mean by that is this. So let's run it. Oh, we have an error. What do we do? Expecting EOF found if. Interesting. So a lot of what we'll do here is try to figure out how our errors are failing here. And so it looks like we did something dumb. Where is it? Sketch exception, expecting EOF found if. Interesting. So it doesn't like this if right here. So what did we do wrong? Did we mess up our parentheses? Perhaps? Did we screw up our comments? What if we get rid of that comment? I'm expecting EOF found if. And I'm not really sure what EOF means, so we might need to Google that in a second if we can't find a really easy error. Oh, I found it. It's right here. Do you see it? I didn't put the curly bracket to go with this one that highlights it. So that's going to be a pretty big problem. So now if we run the code, you can see here that our paddle works. But you can see the ball bounces back before it hits the side of the screen because all we did was move the bounce threshold over 20 pixels. So that's dumb. I want it to only bounce now and then miss it if it was down here. So this isn't exactly what we want, and it's because we're not being smart enough with the other direction. We're controlling in the X direction when the bounce happens, but we're not asking if it's correct in the Y. So over here we need to add a condition. So we want this to be true, but we also want another condition to be true. So we want to say and. Okay, so and something else is true. Well, we want ball Y, which doesn't exist yet. We want ball Y to be greater than, how much bigger? Well, we want it to be below the mouse, but not longer than the thing. So we want it to be greater than mouse Y, which means that the ball is underneath the mouse, just like the word rectangle is right now. But we also want it to be above or closer to the top of the screen than the end of the paddle. So we want to say and ball Y is greater than less than mouse Y plus the width of the paddle, which is 80. Whoops. Okay, we're going to put this stuff in parentheses just so it doesn't get all messed up, so we can actually tell it apart. So this is pretty complicated here, guys, and we're going to end on this comment. This is the fanciest thing we've done so far. We have 3 separate conditions, and they all have to be true for the ball to get bounced back. The ball has to be over the threshold of the paddle in the X direction. The ball has to be further down the screen than the mouse, but it also has to be further up the screen than the end of the paddle, which is some arbitrarily rectangle we drew in space. And the other problem is we don't really have a variable for ball Y. If we try to compile this, it's going to complain and say, hey, I can't find anything about ball Y. What are you doing? Well, we never created that variable. So up here, we probably better make another variable called float ball Y. You notice that it doesn't come up in its own separate color, so it's a variable you're making. We'll come down here to where the ball is made. We'll say, well, where do we put it? Well, we put it 300 pixels down. So we're just going to tell the computer it's 300 pixels down. And then just for consistency, we're going to put that in there. Okay, so when we draw the ellipse, we're going to keep control over ball x and ball y as variables, even though we really didn't do anything. We just sort of moved the number 300 around. So let's compile this and run it, and boom, now, uh-oh, our ball left, and we lost the game. Oh, it's in Nebraska. Oh, and it finally came back. Interesting. Wonder how that happened. So now it bounces. I wonder why it came back. Isn't that curious? Bounce. But now if I miss it, you can see here that the ball fails a condition. It fails one of our ifs. It's further down the screen than the mouse and the end of the thing. But as soon as I do this, the ball comes back because the game isn't quite smart enough to know when we've lost the game. Isn't that curious? So in the next video, we're going to make the ball bounce in 2 dimensions, and then we're going to fix that way of cheating there, that kind of cheat code that we just figured out.